Hello everyone, this is Mula Venkata Kondareddy. Today we will understand a real-world Azure architecture used for video upload, processing, event triggering, background work, and metadata storage, specifically designed for scalable .NET applications. The pipeline begins from the user/media app, typically a mobile app, web app, or a .NET Core Web API that you build. This API receives a large unstructured video file from the user and uploads it to Azure Blob Storage. Blob Storage is ideal here because videos are large, unstructured, and need to be stored reliably without worrying about physical servers. Inside Blob Storage, the video is placed in a container, which acts like a folder. In this case, it's a container dedicated to storing media or videos. Once the video is uploaded, it automatically triggers an event message using Azure Event Grid or Event Grid plus Event Hub, depending on design. The most commonly used source is Azure Event Grid, which listens to the Blob Storage upload event. It then sends a notification saying, "A new video has arrived, start the next step." This removes tight coupling between upload and processing, following the principle of decoupled microservices that you already explored while learning CQRS and MediaTR architecture. Now the event message places a task into Azure Queue Storage. Queue Storage is a simple but powerful message queue system. Here, it stores a message requesting thumbnail generation, like process_thumbnail, video 1.23.mp4. Queues make the system reliable because even if the processing service is temporarily busy or offline, the message stays in the queue until a worker picks it up. Next, we have the worker service, which could be implemented as an Azure function or a background worker, such as a .NET worker service hosted in App Service or Container Apps. This service reads the message from Queue Storage and starts processing. In our example, the worker generates a thumbnail from the uploaded video. Once the thumbnail is created, the worker saves it back into Blob Storage as a new file, completing step 4A. After storing the thumbnail, the worker service updates metadata into Azure Table Storage. Table storage is a NoSQL structured storage used for fast key-based access. It stores fields like video name, upload time, user ID, thumbnail link, processing status, etc. This helps applications retrieve media details quickly without scanning the entire blob container. Additionally, the architecture also shows Azure File Storage, which provides a shared folder system that can be mounted to VMs or legacy app servers. This is useful when traditional applications need access to uploaded files via SMB protocol, especially when working with multiple app servers like Server 1 and Server 2. File storage acts as a centralized shared upload folder. This entire design ensures upload and processing are not directly dependent background tasks, are queued reliably, media is stored cost-efficiently in tiers, metadata is accessible using NoSQL, legacy apps can still connect using file shares. In summary, this pipeline is highly scalable, secure, and cost-effective, making it perfect for modern .NET cloud-native development. Thank you.